Hey math enthusiast, I'm here to go over some notes on proving triangles are similar using angle-angle, side-side-side, and side-angle-side. Now the first part of the note starts off with this postulate, which deals with two angles in my two triangles. Now remember, in this case, I'm not trying to show that the triangles are congruent. That's not the case here. What I want to show is that the two triangles are similar. So I'm showing that there's some relationship between them. If they are going to be similar, then all their angle measures have to be congruent. So I can kind of see that marked in my picture. K is congruent to Y, J is congruent to X. But in this case, I'm only referring to two angles. What I'm using in this postulate is actually that third angles theorem that we discussed earlier in the year. Because as soon as I know that two angles are congruent in these two different triangles, I know I can automatically mark that third angle as being congruent. So as soon as I see that two angles are congruent, I know my triangles are going to be similar. So for my first couple examples, I just want to determine, are the triangles similar? If they are, then I'm going to include a similarity statement to go along with it. For this first example, A, it appears that angle R is congruent to angle F. They do give me a 71 here and a 31 up here. So what I want to try to do is figure out, how big is this third angle? How big is angle Q? How big is angle H? Well, I know my triangles are going to add up to 180 degrees, and it looks like after I subtract the two angles that I do have, angle Q is 31 degrees, and for the triangle on the right, angle H is going to be 71. So it's up to you, whichever two angles you want to focus on. So now I can clearly see, 71 is congruent to 71. I have my two angles, so I can say the triangles are similar because of angle-angle. Last thing I want to include is that statement. So let's say triangle PQR is similar, and then I want to make sure it matches up. So it looks like P, the 71, goes with H. Next letter I went to was Q. It looks like Q is going to go with G, and then obviously the last would be F. For B, I can start off the same way. I'll mark the angles that I do know are congruent. So it looks like angle P is congruent to angle H. They're both 27. But the next thing I want to do is figure out how big is the third angle in each of these triangles. Well, once again, I know they're going to add up to 180. And when I subtract the two angles that I do have, the 53 and the 27, that tells me that angle Q is going to be 100 degrees. Which is not congruent to angle G, which is 110. So for this problem, these two triangles are not similar. For number two, it's a similar situation. Once again, I want to show that the two triangles are similar. So for A, I'm referring to RTV. So let's highlight that one in red. And I'm referring to triangle RQS. So that's the larger one down here. Now, right away, what sticks out is obviously the 49 and the 49. Those two must be congruent. But the thing is, since my triangles overlap, they're going to share angle R. If I were to draw them separately, so we got TRV, and my bigger triangle is QRS, obviously they're going to share angle R. That angle is in both triangles, so it has to be the same measurement, whatever it is. So in this case, I do know my triangles are similar because of angle-angle. So for B, the two triangles I'm focused on are LMN and NOP. So obviously the first thing that sticks out once again is that they do have a pair of congruent angles. The other thing I notice here is that we have some parallel sides. So I'm talking about this side right here, MN, and this side right here, OP. Now remember, what I'm looking for is try to figure out what other angles are congruent. All right, these parallel lines are going to help me, because if I were to focus on this right here, all right, so remember these are my parallel lines and this acts as my transversal, that means I'm going to have some congruent angles. All right, it's going to be this angle and this angle right here. All right, if you remember, those two are corresponding, if I can write this, corresponding angles. So let's clean up our picture a little bit now that we know what angles are congruent. So because those lines are parallel, I know that this angle right here, MNL, and this angle over here, OPN, are congruent. So my triangles have to be similar, once again because of angle. So remember, for these problems, look at those parallel lines. They give you them for a reason. All right, they're going to lead to some pair of angles that are going to be congruent. So number 3 is a little different. They're talking about this A-frame building. They give me a bunch of measurements. The balcony is 16 feet long, 16 feet high off the ground. It's parallel to the ground. And the building is 28 feet wide at its base. So they have all these marked in my picture. What I'm trying to figure out is how tall is the A-frame building. So from that highest point straight down, how tall is that? That's what I want to know. First, let's focus on the two separate triangles. So we have this one up top. We'll draw that off to the side in red. I know my base is 16. All right, then we have a larger one which contains the smaller one in blue. We have 28 down here, and I know part of this is 16. All right, I'm not really sure how to mark that in my picture right now. I know, let's say this goes across, and this portion right here is 16. Now, I'm not really sure how tall the rest of this is right here. Now, remember, they also told me that these two sides are parallel. All right. Now, much like the last problem, when I said when I have parallel sides, I can pick out some congruent angles. So whether you want to focus on these two or these two, it doesn't matter. All right, they're both going to be corresponding angles. So I can mark them as being congruent. Or you could state that this top angle in my two triangles must be congruent in both of them because they share that angle. So either way, I know these triangles are going to be congruent. I know they're going to be similar because of angle. Okay, as soon as I'm stating that they're similar, now I can try to go through and solve for their height. All right, so remember, this is what I'm looking for. All right, I want to figure out how tall it is total. All right, so I'm going to need this top piece right here. As soon as I get x, I can just add this 16 to it and get the full height. Okay, well, if you remember what we did last section, I want to set up a proportion. Okay, so let's compare their bases to one another. So I can do 16 to 28 equal to, and then let's compare their altitudes or their heights. So it would be x, and then for this one on the right, it would be the whole segment, which would be x plus 16. As soon as I have my proportion set up, we can cross multiply and try to solve this. So I'm going to have 28x equals 16x plus 256. Then I'm going to end up with 12x equals 256. And after I divide by 12, I'm going to find that x is 21.3. So now I can add that into my picture. This is 21.3. This is 21.3. Last thing they want is the actual height. So remember, the height includes the 21.3 and the 16. So when I add those two up, I end up with 37.3 feet for my final answer. Next part of the notes brings us to our first theorem. So in this case, I'm just referring to the side lengths, okay? The angles don't matter. As long as I can show that all three sides are proportionate, I'm going to know that my triangles are similar. All right, essentially what I'm trying to do is set up a proportionality statement and show that it's equal. So if you remember what that was from the last section, I want to say that the ratio of AB to RS, so AB to RS, is going to be equal to the ratio of BC to ST, so these are the two bases, is going to be equal to the third sides, AC to RT. Right, that's what I need to prove that these ratios are equal. So for the next problem, I want to figure out which two out of these three triangles are similar and figure out what their scale factor is, which is going to be easy after I show that they are similar. Alright, so this problem is actually going to be quite a bit of work because I need to go through and check to see are triangles 1 and 2 similar, are triangles 1 and 3 similar, and are triangles 2 and 3 similar. Alright, only one of those pairs is going to work. Alright, let's start with 1 and 2. So let's match up some sides. So I want to show that AB and DE are proportionate and show that that is equal to the same ratio as AC to DF, and show that that is equal to the third sides, which would be 16 over 12 EF. Now, to check to see if they are actually equal, what I want to do is just reduce all these as much as I can. So it looks like we end up with 4 over 3, and that should be equal to, well, now we end up with 5 over 4 for this middle ratio. Alright, at this point I can already see that they're not going to be equal. So I already know that triangles 1 and 2 are not similar. So I can stop right there. I don't have to continue any further. I mean, I can see that this one's going to turn out to be 4 over 3, but that doesn't really help if the middle ratio is not 4 over 3. So let's get rid of this and move on to another pair. So I tried 1 and 2. Let's check out 2 and 3 and see if those two are going to be similar. So first two sides I'll focus on, we'll go with the 18 and the 30. So I'll set up my ratio for that, 18 over 30. I want to check to see, is that going to be equal to 16 over 25? And I want to check to see, is that going to be equal to my third sides, 12 over 20. So once again, it might not be obvious if these are actually equal. So let's just reduce them and see if we can figure out if they are equal. So it looks like I'm going to end up with 3 over 5. But when I come to this middle ratio, it looks like I can't simplify it. So I'm going to be stuck with 16 over 25, which I can already tell is not going to be equal to 3 to 5. Alright, once again, I can do the last one if I really want to. That will give me 3 to 5, but it doesn't matter. It's not equal to that 16 over 25. Alright, so in this case, once again, now I know that 2 and 3 are not similar. Well, at this point, I'm only left with triangles 1 and 3. So that's the last pair I'll check just to ensure that they are similar. So we'll check these longer sides, 24 to 30. Now this should definitely be equal to 20 to 25. And that should definitely be equal to the third side, 16 to 20. So now it looks like when I reduce these, divide them both by 6, I'm going to end up with 4 over 5. Divide them both by 4, I'm going to end up with, divide them both by 5, I'm going to end up with 4 over 5. Lastly, divide them both by 4, I'm going to end up with 4 over 5. So it works out. All three of my sides are proportionate, so I know that they are similar because of side, side, side. And as far as the scale factor goes, I've given it right here. All right, it has to be 4 over 5 because that's what all of these ratios reduce down to. So once again, that's telling me for every 4 units on triangle ABC, it's going to be 5 units on triangle GHJ. For this next problem, I want a value for x that's going to make these two triangles similar. Now, if they were indeed similar, that means that all their sides would be proportionate. So that means I could set up a statement of proportionality showing that all these ratios are going to be equal. So I could say that BC is proportionate to EF, and lastly I could say that AC is proportionate to DF. So what I want to do is try to use this information to then solve for x. Obviously, I'm focused on this side, which corresponds to this side. And I can use these two since I actually have these two side lengths. So out of my statement of proportionality, I'm just going to focus on the first two ratios that I wrote down. So let's replace all of these values with their lengths from the picture. So AB is x minus 3, DE is 20. On the other side, I'm going to have BC, which is 4, and EF, which is 10. As soon as I have my proportion set up, we can cross multiply and solve. So I'm going to have 10 times x minus 3. I'm going to have to distribute that out to both of those terms. So I have 10x minus 30. Looks like I'm going to end up with 110 equals 10x. So it looks like x equals 11. So now that means that my side lengths are going to be 8 for AB. And then it looks like I'm going to have 25 for DF. So if you're really curious, what I can do to check my work is take this statement of proportionality and replace all of these with the actual side lengths that I have. So let's do that down here real quick. So it would be 8 to 20, which should be equal to 4 to 10, which should be equal to 10 to 25. All right, so it looks like if I reduce all of these down, I'm going to end up with 2 to 5, which would also be my scale factor. Now the third way to prove triangles are similar from this section is side angle side theorem. All right, so now this is a combination of the two. It obviously involves one angle and then the two sides. So I'm still showing that that angle is congruent. All right, because all angles are congruent in similar figures. All right, but then I also want to show that the sides that make up that angle, so like in this case, if I'm referring to angle X, I want to show that XZ and MP are proportionate to XY and MN. All right, the two sides that make up that angle. So let's just copy that down here real quick. I want to show that XZ to MP is proportionate to XY and MN. And obviously I want to show that angle X is congruent to angle M. So the next example is similar to the one we just did. I want to find a value for X that's going to make these two similar. Well, I can already see that we have a pair of angles that are congruent, 60 and 60. All right, and it looks like the sides that correspond, according to my statement, it looks like QR goes with UV. So QR goes with UV, and it looks like PR, the side on the left, corresponds to TV, this side on the left. So based on that, I should be able to set up a proportion. So we'll start with the blue sides. We can say 30 to 24. That ratio should be equal to 3x plus 4 over 20. Once I have my proportion set up, we can cross multiply and solve. So I'm going to end up with 600 equal to, we're going to have 24 times 3x plus 4. So I'm going to have 72x plus 96. I still have 600 over on the left. I'm going to end up with 504 equals 72x. And lastly, when I divide by 72, I'm going to end up with x equals 7. So let's go back to our picture. So I just said x equals 7. And if that's the case, that's going to make this side 25. So now I can just go through and check to see, does my statement of proportionality work? So 30 over 24, is that going to be equal to 25 over 20? All right, it looks like when I reduce them down, I'm going to end up with 5 over 4 for both of them.